Night has fallen on Rocket Lab Launch Complex 1, the world's first private orbital launch site. Our Electron rocket is standing tall and ready on the pad in Pad B in Mahia, New Zealand, as we count down to today's launch for NASA. Thanks for joining us for our 48th Electron launch and our 6th mission of the year, scheduled for liftoff at 19:28 local or 7:28 UTC. It's bright and early for our Eastern and Pacific viewers, with a liftoff time set for 03:28 Eastern and 28 minutes past midnight Pacific. My name is James Rattray.
And I'm Kim Thompson. We're looking forward to another liftoff tonight for NASA. Today is the first of two back-to-back launches on Electron that we're undertaking for NASA's PREFIRE mission, a climate change-focused mission to measure heat loss from the coldest regions of our planet. NASA loves an acronym, so PREFIRE stands for Polar Radiant Energy in the Far Infrared Experiment, which describes the mission objectives for these spacecraft to detect how much thermal energy escapes the Arctic and Antarctica into space. We're supporting this NASA mission with two dedicated launches on Electron to carry one satellite each to a 525-kilometre low Earth orbit on a polar trajectory so that the satellites can travel across the polar regions to make their heat loss measurements.
That's right. Today's Ready Aim PREFIRE launch will set the stage for the second mission, where it will deploy the second PREFIRE satellite on a similar trajectory but along a slightly different path to overlap with the PREFIRE 1 every few hours near the poles. So what's all of this got to do with climate change? Well, the amount of heat energy that Earth receives from the sun should ideally be balanced out by the amount that Earth radiates back out into space. The difference between those energy levels is what determines Earth's temperature and influences its climate.
Extreme storms, flooding and coastal erosion are all examples of what can happen based on what's going on in the Arctic and Antarctica. To be able to better predict climate change, scientists need a full understanding of the heat energy balance happening at the poles, which is exactly the type of data that PREFIRE is aiming to provide. For more about the mission, here's NASA.
The Arctic is warming 3 times faster than anywhere else on Earth.
This is a huge problem, in part because that is enhancing melt of the ice sheet. It's leading to enhanced melt of sea ice.
All of the coastal communities around the world are now seeing sea level rise around them and experiencing increased flooding.
It will impact the future generations. They're going to inherit a planet that's going to be many degrees warmer than what we are today.
We need to have better predictions of how sea level will change, how the weather around the planet is going to change. The only way we're going to do that is to understand how the polar regions are responding to climate change.
We have this considerable knowledge gap in our understanding of Arctic climate.
PREFIRE is going to fill this important gap.
PREFIRE, Polar
Radiant
Energy
in the Far
Infrared
Experiment.
So Earth's temperature is set by a balance between the amount of energy the Earth receives from the sun and the amount of energy that it emits back to space.
Most of the energy that is radiated to space from our polar regions is far infrared energy, and we have no modern satellite observations of this incredibly important energy spectrum. PREFIRE will be deploying 2 cubesats. Over the course of a year, they're going to be measuring the far infrared energy for the very first time that is leaving the top of our atmosphere.
Each of our PREFIRE CubeSats carry something called a thermal infrared spectrometer that looks down at the Earth and gathers energy being emitted from the planet at different wavelengths.
Just imagine a rainbow. When you see a rainbow, you see the different colors in the rainbow, and what happens is light gets dispersed. Similarly, we see the different wavelengths split up, and you can measure each of these wavelengths, and that's what the spectrometer does. It spectrally separates the radiation into different wavelengths.
These wavelengths were going to give us really important information about how the surface is changing in the polar regions, whether that's going from an ice-covered surface to a melted surface, or whether it's going from sea ice to open ocean.
The 2 satellites are going to be orbiting in a polar orbit around the Earth. The first satellite comes along and measures the scene over the poles, and then a few hours later we have the second one come along in a different orbit and measure the same scene, so you understand the impact of how the energy changes in those few hours.
It's really important that we understand how much energy is being emitted by the polar regions, because that defines how cold the polar regions get. And that temperature difference between the warm tropics and the cold polar regions is actually what drives the entire weather system around the planet.
What we want to do with PREFIRE is we want to take these new observations that have never been made before, and we want to improve our understanding of the climate system and improve our understanding of how climate is going to be changing.
Understanding how the sea level rises and how the ice melts is going to help us understand weather events, and that's going to have direct impact on our farmers and agriculture.
There's a real urgency to getting this information now. Things are changing so quickly in the Arctic that we may only have 5 to 10 years to respond to those changes and help protect the property and lives that may be affected by that.
LOX load is complete. System is in recirculation. Anti-gravity is disabled.
Stage 1 and Stage 2 tanks are pressed for flight. High flow engine purchase enabled. T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Beginning pitch over. Stage 1 propulsion.
And with that, we have liftoff from Launch Complex 1 of our 48th Electron mission. Ready Aim PREFIRE is in the air and on its way to space with its NASA payload. Soon we'll be hearing the call out for max Q, otherwise known as maximum aerodynamic pressure, which is the point during Electron's ascent where the structure is under the most amount of stress. We'll hear from the GNC operator shortly that Electron has cleared that milestone.
High voltage battery discharge is nominal.
Cleared max Q.
And that was the max Q milestone, passed cleanly through by Electron as it carries on its mission to orbit for NASA. We're now at over 18 kilometers in altitude and moving at over 2,400 kilometers an hour. Next up will be 3 actions that are performed by Electron back to back to back. The first is main engine cutoff on the first stage, when all 9 Rutherford engines will shut
Guidance
down.
is nominal.
Next is stage separation, when the booster disconnects from stage 2, and then we will have second stage engine ignition, when the Rutherford engine on the second stage lights up to carry on with the mission. Those call-outs should be heard as MECO, stage separation, and second stage ignition. Let's listen in now.
Stage 1 propulsion holding nominal. Stand by for MECO in 30 seconds. "15 seconds to staging. Anti-burner detect mode. MECO confirmed. Stage separation successful. Stage 2 ignition confirmed. Fairing jettison succeeded.
Pulse swap successful.
Another milestone down, that was battery hot swap for the second stage Rutherford engine. All is continuing nominally for Electron, its engine, and the mission as we carry on past 210 kilometers in altitude at more than 15,000 kilometers an hour. The next actions for the second stage will then be some of its last, including shutting down the Rutherford engine for SECO before separating the kick stage and NASA's PREFIRE satellite. Those milestones will happen back to back just after 9 minutes into the mission.
HVB battery discharge holding nominal.
T plus 7 minutes 46 seconds into this mission. The engine that you see on your screen is Electron's Rutherford engine. Now, as Kim mentioned before, the sea level version of that engine is capable of 5,600 pounds of thrust, and the vacuum version you see on your screen now is capable of 5,800 pounds of thrust. Now, Electron's total at liftoff is about 50,600 pounds, and compare that to a single Archimedes engine for our upcoming neutron rocket. The single Archimedes is capable of 165,000 pounds of thrust, which is the equivalent of 3 entire Electron rockets or 27 Rutherford engines on their own. It's now T plus 8 minutes and 30 seconds. That means we're coming up to the second stage engine cutoff for this launch, which is an action very similar to what Electron performed for the first stage separation earlier in the count. And much like before, Electron will power down its engines before separating the kick stage with its NASA payload. The timing of that shutdown is expected right as we reach our target 200 kilometer perigee. So let's listen out now for that engine shutdown and stage separation.
SECO confirmed.
Stage 3 separation confirmed. Nominal transfer orbit achieved.
And just like that, 9.5 minutes after lifting off, we are in space. The second stage engine has now shut down, and the kick stage has separated, ready to perform its own specific maneuvers to place NASA's payload into its target low Earth orbit for the PREFIRE mission.
We have a while to go until the kick stage completes its first half lap of Earth. It's at that point, when we're on the opposite side of the sphere to where we are now, that the kick stage will fire up its Curie engine to circularize its orbit ahead of release of the PREFIRE satellites out into space.
We'll be back on this webcast to listen through those final calls at around T plus 50 minutes. We'll see you back here then. There you have it. The kick stage has successfully deployed NASA's PREFIRE payload. Congratulations to the Rocket Lab team on another mission success for Electron. And to NASA, welcome to space for the PREFIRE mission. We can't wait to be back on the pad with you again soon for the second PREFIRE launch on Electron in the coming days.
With only a few days until the next launch and then Electron's 50th flight shortly after that. It's crazy to think we lifted off the pad for the very first time 7 years ago. In fact, 7 years to the day, May 25th, 2017. For now, though, we'll say goodbye and we'll end the broadcast here, but keep across our social media channels for all other updates about Rocket Lab and our upcoming missions.
Until next time, thank you so much for joining us for today's launch. This is Rocket Lab Mission Control signing off.